All right, welcome back, everyone. We are finally in week 5, where we're not going to be touching much code anymore, and we're going to be working on more deployments. So today we'll be looking at containerization and start with some announcements. So PA4 is due today, and PA2 is graded. We have the hack challenge coming up. So here are like a couple notes. You have to join the hack challenge ed discussion. So it's a separate ed discussion. It looks like something like this. It's like a brand new ed discussion. Let me zoom in. And if you look at the like Ayush, what he posted, you can see like the full schedule here. So tomorrow, Tuesday, we have a hack challenge mixer. It's like if you don't have teammates, this is where you're gonna find your teammates. So that'll be like a place where all the iOS, Android designers, backend people, you can all meet and find teammates for the project. And then on this Thursday, we have the kickoff where you have to be there as required. You'll reveal the teams, introduce a challenge, and then we'll go through the whole timeline. And then you guys have 2 weeks to build. And then Thursday, December 4, we have the day before, we have the midnight office hours, which is like office hours that goes all the way until midnight to help you guys like finish everything. And then Monday, this is the finale where we have like finished judging and we present the prizes. Does anyone have any questions about the hack challenge?
Yeah, so you don't have to go to the mixer. You can just fill out the form if you just feel like if you just want to be randomly assigned to a team, like that's fine too.
Yeah, but highly recommend the mixer because that's where you're gonna find like if you don't want to be mixed with randoms, then that's where you find the people. Unless you guys have friends in the other courses. But all right, let's continue. And don't forget to join the ed discussion. The link I believe is shared in our ed discussion, so just remember to join that one. Also, if anyone has any like questions about implementing the backend later for the hack challenge, any idea brainstorming, you guys can talk to us, and we can like give you guys advice and tips and see and you guys can like see what works in the past. Right. So this is the course so far. All the coding is in 1 to 4. We've done routes, we've done databases with SQL, relational databases with more SQL, and then abstractions where we like go away from SQL. Now we have the next part of the course, which is containerization and DevOps, which we'll be doing today. Deployment and services, hack challenges. I mean, that's not a part of the course, but that's just what we have, which you guys will be starting in a bit. And then images, authentication, and other topics we have at number 8 later. Right. So let's go for a little bit of review.
Okay, so remember last week we went through ORMs. So essentially, if you need a little bit of a refresher, these uses objects and classes to interact with the database. So now we're using classes in Python instead of tables in SQL. So ORMs makes the job a lot easier for us. It translates SQL to Python, and it automatically handles enforcing reference conditions and manipulating join tables. So now that you have, why is it paused? Oh. Yeah, so now we're gonna go into the deployment process. So you've created your app, you've created your backend project. How do you have other people use your app as well? First, we're going to define what a dev versus prod environment is. So a dev environment is short for development environment. So this is the environment that engineers write their code in. So it might contain print statements, debugging, logs, a lot of testing. So this is just for engineers to play around with to make sure that their app works. And production environment is different. So this is the environment that actual users are going to interact with. So we want to make sure that this is very clean, a very error-free code. And then the deployment process is 4 main steps. Today, we're going to go over the first 2 steps. So the first step is compressing the code into a production environment. And Um, so remember, production environment is the environment that other users, other consumers are going to be using. And then once you have that production environment, you have to prepare it to be run ready. So yeah, let's get into that. Oh, before we get into that, how do we run apps on other machines? So far we've been working on local servers, which means just like our own computers. We've been writing our code in app.py, db.py, and we run it on Postman, which is run on our local server, which is our laptop. But we haven't seen how users can run these apps on other machines. So we don't know how other users can use our apps. And why do we want to do this? So in production, we don't want our apps to be running off our local machines. Instead, we will be running them on other machines, which, in other words, are servers. So say, for example, we have Eatery. So Eatery is used by a lot of people at all times of the day, right? So if I like ran Eatery on my own laptop, and then say if I go to bed and like I close my laptop, then that means Eatery will be down until I open my laptop back again. So that's why we don't want to be running our apps on our local machines. Um, and we want to run them on other machines on servers. So we've talked about dev environment, we've talked about production environment, but what is like an environment? So an environment contains four main things. So an operating system. Operating system is like a Mac or Windows or Linux. Your code, obviously, all the libraries that you have. So in the past, we've had the request library, the JSON library. We've recently been using the SQL Alchemy library. So those are some examples of libraries. And then we also have environment variables. So we'll talk about that. So these are just like examples of like what could be contained in an environment. Um, And yeah, so we talked about all of these. So what is an environment variable? So this is really important and it's essentially a file containing confidential information. So a lot of sensitive information is in our source code, but we don't want that to be directly accessed by the public. So this is like username and password combinations, API keys, passwords to like our databases, things like that. So we don't want everyone to have access to those secrets. Um, yeah, so to do this, to make these like environment variables, I guess like not accessed by the public, we define these variables in a different file. So this is going to be called a .env file. So for example, this is how you connect to a Postgres database. And a Postgres database is just um, we've used SQLite 3 as a database, but there's another database called Postgres, and this is an example of how you would access the Ithaca Transit database. So you have the host, the database name, the user, the password, and this is all in the source code. But we don't want this in the source code because someone else can just like see what all of this information is in the source code and like log into the database themselves and like add stuff to the database, remove stuff. So we don't want that. So that's why we have a different file called .env to contain all of this sensitive information. So you would define like the database name here, the username, the password, and to change the source code, you would change it like this. So you would access the .env file using os.envirn, and then it calls the database, and then it will replace this with like this, whatever is in these quotes. So the .env file cannot be accessed by the public. It's only accessed by the server. So, so to access the environment variables, you would have to SSH into the server and then create the same .env file in the server. So that's kind of confusing. So it would look like this. So on your computer, you would have the .env file in your system, and then in the server, you would also have the same .env file. But then you yourself put those environment variables in the server. Like you logged in, like for say I logged into the server and then I put the .env variables because only I have access to those. Does that make sense?
Question, so only like the developers can SSH into the server.
Essentially, yes.
So like how this works is environment variables, just imagine like a computer, like you know how like your Python files can have variables like let a equals x, like a equals 10, blah, blah, blah. Your computers can have variables. So what environment variables are just you can think of it just like variables specific to a computer. It's like this laptop, my laptop may have like environment variable like x equals 10. Lauren's laptop might have like x equals 8 or something like that. So each one of the computers, they have their own environment variables. And what we're saying here is we don't want to store sensitive data like how like login information to the database. We don't want to store that in the source code or like our app.py because if someone gets access to app.py, and usually it's like a team of developers, if you accidentally show someone take a screenshot or anything, they can access our database. Instead of that, we make it so that our computers are the one that stores the variables. And it's much harder for someone to get access to a server or my computer. So it's safer. That's what we're trying to say. Does that make sense? So later on, when we're deploying, usually what we do is we just copy the environment variables. So I have environment variables in my laptop when I'm coding. When I deploy it in the server in Google Cloud later on, I'll just be copying over the environment variables to the Google Cloud server. And we'll show an example of this later on. But yeah, just think of it as like variables for a computer. That's basically it. Sure. Next one, you.
You want to go?
All right. So now let's compare what you guys have been doing with how we would do something in production. So right now, what you like the process you guys that we taught you guys how to do is you install Python 3, that's your language, right? Then you install requirements.txt. These are all your libraries that you need, like you need Flask, you need works or like all the other libraries you need. Then you run your app with Python, and then that's it. That's basically the whole workflow, right? It works fine for simple applications, but it can get much more complex when you're working with a production level database. So a large scale approach would look something like this. So you have a separate database, so that's another server. You have more custom package installations. You have like you need like for example, one part of your backend needs Python 3.2, one needs Python 3.4, something like that. They're a bit outdated, but yeah. So this might need more work than just what we've taught you. You might need to manually isolate environments if you want to, for some reason, separate, like for example, processing with the routes, blah, 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 blah. And in general, the setup becomes very cumbersome and we need a better way to do this. So yeah, we want a modular and automated solution. So how do we do that? Virtualization is the old way to do this. And yeah, let's walk through what virtualization is. So a virtual machine, it's basically a computer inside a computer. And it allows you to set up an OS to run. And sandbox from a host computer file, essentially like you can run a Mac inside a Mac, and you can run multiple Macs in a Mac. So like my Mac, I could like run Windows, I could run Linux, I could run Mac OS all in the same laptop. And it looks something like this. So you have this is the whole computer. I have a hypervisor here, which is to manage all the different virtual machines. And these are all virtual machines. These are all like mini computers within this big computer. So inside that mini computer, I could run app.py here. I could run another backend here. I could run another backend here. And all of these, they have operating systems inside of the virtual machine. So that's why I said, like, imagine this is my whole Mac. And in my Mac, I could have like a Windows virtual machine here. I could have a Mac virtual machine here. And I could run different apps. However, this is let me get into why this might not be nice, because you have to, first of all, there's many operating systems. You also have to manage each one of these as a like individually. And I'll just wait for the slide when we talk about why this is bad. So the solution is containerization, which is similar to virtual machines, but what we do is we're basically zipping or compressing code into a production environment. And then we spin up a server, and all we have to do is run that zipped or compressed files. So we basically zip it and then we just run it on the server. And it looks something like where's the diagram? I want to show the diagram, but the diagram's not here yet. Yeah, that diagram. Wait. Let me skip over so it's clear. The diagram looks something like this. So you have the same like computer, and then you have one operating system. You don't have multiple operating systems. You have one. And then you have Docker. Docker is the app that we will use to compress the files. And in just by using Docker alone, you can manage like a bunch of apps all within one computer. And the advantage is like you don't need to manage different operating systems. You just have one. And it's just much faster and more efficient to use Docker. And there's a slide later on the advantages. But does anyone have questions about this so far? Okay, let me get into Docker first. Maybe there'll be more questions later. So, okay, so what is Docker? This is the symbol for Docker. It's like a whale with containers on top, and it'll be more clear later why. But containerization is equivalent to neatly packaging, similar to like zipping a file and compressing a file. It allows developers to package code into a standardized unit of software. So yeah. And what you do when you zip is the zip file, usually you call it like a zip file on your laptop, but we call them Docker images. So when you like containerize or when you compress your app, it becomes a Docker image. And then when you're running it, when you're unzipping it, you run it as a container. That's the vocabulary here. So an image and a container. Okay, just follow along for now. And then this is what a Docker image is. So images are like compressed files built from source code, like your app.py, db.py. And what a Docker image is it's a snapshot of an application and its environment. So it's like you grab a snapshot and you compress it basically. And later on, we'll see how to configure this snapshot, and we'll be using something called a Docker file to configure that. And what a Docker file is, it's just a set of instructions for you to allow to build a Docker image. So on like Mac, I can show an example here, like a very quick example. Let's say I have this like file system. If I want to zip app.py and db.py, I can like right click here and then press compress. And I get a zip file, right? An analogy for that using Docker is I have an environment here. And then when I right click and compress, I will follow what instruction I have in my Docker file. It sets like it's a bunch of instructions that tells me how to compress. And then what I get is a Docker image. That's the analogy. Yeah. And then when I run this, like when I open this, like I double click and I open it to become a file, that's like running my Docker image as a container. So that's sort of a terminology you have to get used to. Question?
Docker file, like a make file,
Sorry?
like a make file.
I know what a makefile is, but I'm not sure if it's equivalent. I think you're getting to the point, but I'll show you what a Docker file looks like after this, but it's a list of instructions to compress the file, to compress your code base, basically. Yeah. We'll see an example after this, but hopefully this makes sense. And then we'll run these later, but to unzip the file, you run docker build. And to see all the images you have, to compress, you run docker build to build the image. And then to see all the images you have, you just run docker images. We'll have a demo of this after this. And then when you run the docker image, you have a container. So you run containers from an image, and it's just a live Instagram app. It's just a running app you have. And you can run it using like docker run, and you can run docker ps to see all the containers. So this might sound like a bunch of jargon, but let's clarify everything. Yeah, this is how it looks like. So the code is not here, but imagine like the code is right here. Like this is your app.py and db.py right here. Docker file is a set of instructions to tell you how to build into a Docker image, which is like the compressed code base. and then you have the Docker image, and you can run it as a Docker container. Yep. So that's the whole process. I don't want to draw it. Does anyone have any questions so far? It's very abstract and it sounds weird. Yeah.
So how does the code turn into the Docker file?
The code doesn't turn into a Docker file. The code turns into a Docker image following a set of instructions listed in Docker file. So Docker file later, this will say like, oh, I want you to like install this package, and then execute the app at like using Python app.py, blah, blah, blah. So there's a list of instructions which will convert your code base into a Docker image. And then when you run it, all you have to do is unzip and it will just run.
Like runs multiple computers with like different, like maybe different operating systems.
Yeah.
Than your Mac or like whatever you use. And then a Docker, like you can run multiple apps within one like operating system.
Yes. So all you have to do is you install Docker, the application. It's like a management system basically, and it'll run all the apps for you. You don't have to deal with different operating systems. You don't have to deal with different machines inside your machine. Does that make sense? It's more complicated because you have to like it's multiple machines inside a machine compared to just one machine with all your apps running by itself. And you'll see why it's quite smooth to use Docker, and we'll see in the demo after this. Yep, good question. Right. So images are to containers like blah blah blah. These are like a bunch of metaphors. So you can think of an images, a Docker image, you can think of it as like a class, like a blueprint. Like in Python, you have different classes, and containers are just instances of that image, so like objects. In case of blueprint is how you make a house, and house is the actual object. Images is how you make or run the app. Containers is actually the running app. And recipe and cake is the same thing. Like image is like I'm not gonna go through all of this, but one is the instructions, one is the instructions of how you do something. Container is the actual running thing. And this was the image from just now about how Docker works. Let's continue. The benefits. So you want to take this one? Okay. So the benefits, it's a better application management system. It's more compact. You only need Docker. It requires fewer resources. I'm not sure how to explain this, but you don't have to run multiple instances. You don't have to run multiple OSs. So it's definitely more efficient. You can boot up applications faster. You can see later how fast it takes to just boot up an app. And it's simple and more modular. You can manage all of it through one system, which is Docker. And this is number 2. So we have something called Docker Hub. If you guys, we've taught GitHub. So GitHub is essentially your code. You upload your code to the cloud and it's stored there and everyone, like people can see it. Docker Hub is just uploading your images. So the zip files, you're uploading it to Docker Hub. And from there, people can grab the image and run the code as a container. Yep, I think I've gone through that. And yeah, you can also set it to private and public, depending on if you want to open source your code or not. And this is what we use for remote servers. Like we'll have a Google Cloud server later, and what it'll do is it will access Docker Hub to get the code. So I think here's a good place to draw a diagram. What's next? Here's a diagram actually. But I don't really like this diagram. So like imagine you have your code base here. On the left, there's out there. You create the instructions to build, and then you build with the instruction, the Docker file. And what you do is you push the image to Docker Hub. So you upload your zip file basically to the cloud. And then later on, you can pull that image down and you can run it as containers. So that's why the logo is like a whale with a bunch of containers, because it's containers. Does that make sense? Yeah. Yeah. But later on, this will be in our local computer. Like on my Mac, I'm gonna run build. So I'm gonna build the image, compress it. I'm gonna push it to Docker Hub. And then later on, I'm gonna go into my server in Google Cloud, and then I'm gonna pull the image and run it on that server. So that's sort of like that's what's gonna happen next week. But yeah, it's the whole thing. Like I like to just say, is this compressing, storing in the cloud, coming like pulling it back down and unzipping. That's basically it. If it's really simple. Then we have Docker Compose. Docker Compose is just for you to run multi-container. If you want like a lot of apps on one server, you can use Docker Compose, which we will use. And it has its own configuration file, Docker Compose YAML. And it's used to define all those different containers you're going to run. And in this course, we're just working with one. But usually Docker Compose is used to run multi-container. But yeah, so there's a lot of things going on. This is Docker Compose. If you want to run multiple containers, let's say you want to run one container, like one app to run Python with your app.py, you can run one container with Postgres, which is your database, or like SQLite, you can run it here. You can run a React app as well. React. This is Flask. I don't know what's doing there, but you can run a bunch of them, multiple containers using Docker Compose. That's why Docker Compose is like their logo is an octopus, because you can run multiple containers. Yeah. So in summary, yeah, you guys can read that, but I would rather like draw something. So you have your app.py. Oh, it's so app.py, and you have your db.py here. This is your routes, remember, and this is your logic. And then what I'm going to add in my code base is I'm going to add a Docker file. This will tell me how to build. This is all local. This is in my laptop. And then once I have these files, this tells me how to build. The next step is I'm going to build into this like Docker image. So I'm just going to draw a Docker image like this. I don't know, something like that. The way I build is using like referencing this Docker file. And then after building, I get an image. This is a Docker image. What I do with the image, I upload it to the cloud, which is like where Docker Hub is. Docker Hub is the like cloud-based solution to store all the images. Docker Hub has like thousands of images of different people's apps, and we're just putting it there. And then later on, we'll have another server here. This is like in the production server, like prod. Here, I pull the app for like my image. My image was like here. I'm gonna pull that here, so then I have my image now. And then I'm gonna run the image as a container. So I'm going to run, and then the image is like a container. Like this is like a container. And my app is running on a prod server. So that's how it all. Yeah.
What does the container act like? I understand the image, and then there's within the image the container, but what's the container doing?
Okay, so the image is a blueprint, and the container is just a running instance of your app.
Okay.
Yeah. And then where does Docker Compose fit in all this? Docker Compose is used to run multiple containers. So when we're running here, this is where we use Docker Compose. Technically, we don't need this, but we're teaching you guys because it's also very useful to specify, Docker Compose YAML and stuff like that. But there's a file here called dockercompose.yaml. It's a YAML is just a configuration file, and that will help you run. So a Docker file, this helps you build, and then Docker Compose YAML will help you use Docker Compose to run images as containers. Does that make sense? Okay.
Oh, you have a question?
Question?
Yeah, so would you put like for example, like the back end in one container and the front end in another? Or
Yeah.
would you like package them all?
That would be a good idea. Yeah, you can do that. The backend course we're only doing backends, but you can run multiple containers. One for backend, one for front end, one for like processing, one to run an LLM. You can do a bunch of stuff with. It's just different instances, like different running things, and you can think of them as like just running a bunch of containers. Good question. Yeah.
So, how would you like make like the backend on that? It's also like for hack challenge where you want to other like members of the classes too. So how would the containerization remember in like a more collaborative environment to like have you
Good question. So normally in the hack challenge, the only one containerizing is you guys. So backend only. We containerize and we run. And then when we run, remember how we have this like running on local host 3,000, 5,000 or something like that, local host. This we'll run it on like 127.00. Like there's an IP, right? The front end people, you just give them this IP. And once they get the IP, if they want to get like a list of all the users, they just do like /users. And that's how they get the information. I'm not sure if front end people actually deploy their apps to the App Store in the hack challenge. I think it's just a demo of the app on their laptop. So as long as you give them this, like your job is practically done. Does that make sense? Because it's not like a full, you're not actually deploying to the App Store. Yeah, good question. Okay, let's move on. Hopefully that I think that matches. Yeah. I think that's it.
Just DevOps.
Oh, DevOps. You want?
Sure. Okay, so we're just gonna define what DevOps is. So it's essentially how to ship software fast. So we've been developing our software. That's all we've been doing. And then operations is testing and releasing that software. So DevOps just means like the intersection of that. So the goal is to build and ship software really quickly and reliably and make sure that going from development to operations is like really seamless. So this is kind of like the cycle. So you would start at like plan, create, verify, package, release, configure, monitor. That's kind of like the DevOps cycle. Yeah, we can go into the demo.
Yeah, wait, let me see.
Okay.
I guess, yeah, this is like when you're planning is when you're like figuring out what tables to make. Like you want to add new features, for example, you plan it first, you code it up here, you verify this means like testing on Postman would fit here. Packaging and releasing, that's what this would look like. So like you're packaging it up and releasing it or like deploying it. And then you're configuring it in the deployment. So like you're fixing if anything goes wrong. And then monitoring it is just making sure it doesn't go down. And then if anything, like if new features need to be added, you go back to the plan and you just like follow this endless cycle of like never-ending development. Yep. All right, let's go into the demo. Hey. So first let's look at what Docker Hub looks like. This is my Docker Hub. You can see it's my account. I can show my account here. It's just my net ID. I logged in with my school Gmail. And I have a couple apps here. These are my repositories, same like GitHub repositories. It's basically like my projects, right? Let's PA5 P5. This is like from last year. That was like 2 years ago. When I click into my repository, you can see I have an image right here. So these are a bunch of images. I mean, this one image. This is an image, like a compressed file. This is one of my projects. And yeah, that's how Docker Hub looks like, basically. It just stores all my images that I pushed. And yeah, we'll talk about the tags and everything about a bit later. And then we have the local Docker. So Docker and Docker Hub are different things. Docker is what you use locally on my laptop, which I'm opening right now. And then Docker Hub is the cloud version. So up there. Where's Docker? No.
Sometimes you have to restart your computer.
No way, bro. I just opened it just now.
But yeah, when you close it and try to open it again, you have to restart it.
Why?
I don't know. I always run into this problem. Wait, but the meeting's connected.
So scuff. I need.
Sure.
Why is it not running?
You can just show that.
How? You have to get into Zoom. It's not even here. Okay.
Zoom.
Yeah. I still have it here. I mean, it still works.
Just showing costs.
Okay, let's just okay. Yeah, my Docker app is not running. Apparently, I have to restart my computer to do this, but let's go into this code base. Let's make it bigger. As usual, we have our normal things. We have app.py and db.py. This is from PA4, I believe. And we have our code. Now we have to make our Docker file, which is like a list of instructions, right? So let's make that. It's just called Docker file. And you can see the whale just pops up there once you name it Docker file. It's a special name. All right. And in the Docker file, you have a couple commands. These are instructions to build your image. So first, we have to specify like what language you're using. So in this case, we're using Python, and the version we're going to use is Python 3.10.5. Let me remove my code completions.
It's good.
The Zoom is ending in 2 minutes.
Wait, that's
Okay.
just starting.
And then the next command we have is a run command. So we're gonna run mkdir, which is make directory. We're making a new folder called user/app. So inside, like imagine when we are like running our app locally, we have Python, and then we make a new folder, and then we set the working directory to user.app. So work directory, that work there, this just stands for working directory. You're setting your working directory, like the folder you want to work in, to be the one you just created, which is user/app. 1 minute. Okay. And then you have this command, which is the copy command. We copy all the files in our source folder and move it over to this new folder. Yeah, this command. So we're inside the source folder. We're grabbing all the code like app.py, db.py, and we're going to copy it over to our new working directory, user/app. That's what the copy line does. And let's stop there and let me make a new Zoom meeting because I don't have the pro one. It's gonna die.